Jennifer Lechner says, Bill, I'm running the University Observatory. Hooray! Congratulations. By the way, I should put up a post when I maybe remember to do it tonight or this weekend. My Facebook friend, James Aubrey, who I worked with, he was 13 years old, and I was probably 15, 8 years older than that. I was probably 20, 22, something like that. The Miami Planetarium, apparently, Miami Museum of Science Space Transit Planetarium closed its doors, I think, last weekend. It opened in 1966. I got there in 1973 and closed in 2015. It's not a bad run for that old Spitz projector. James took some really beautiful pictures of the star projector, and I grew up with that machine. I mean, that machine and I spent, since I still feel attached to it, I ought to feel attached to it. I've got a neural network to run that thing. What would that be? 43 years, something like that. It's a long time. Hang around with a piece of perforated aluminum. It's a fine machine. I'll do a little post on that, I think. Maybe I'll write an essay on that. It'd be a good thing. I haven't written an essay for a while. Anyway, I digress. Jennifer, congratulations on running the university observatory. I ran the Southern Cross Observatory with some other people in the student section for many years. So here's the question. I'll be setting up telescopes and talking to people about the cool stuff they'll be seeing. Do you have any advice from your planetarium days for keeping an audience captivated by astronomy? What makes people go wow the most and what bores them? Great question. I'll give you a one-word answer, and then we'll open up from there, Jennifer. What keeps people, make them go wow the most? Saturn. Period. Saturn. I'd like to say the planets, the moons, deep sky objects, numbers. No. Saturn. It's Saturn. Saturn moves so slowly across the background stars. It is obviously the farthest of the six original planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, Saturn V, sorry. Because we're on number 3. So Mercury was visible to the naked eye: Venus, Mars, Jupiter, and Saturn. And they all move across the background stars. The word planet comes from the Greek word for wanderer. Because Saturn moves so slowly, because it's by far the furthest one out. And by the way, it's pretty much almost a geometric progression. Jupiter's about twice as far as Mars. Saturn's about twice as far as Jupiter. Uranus about twice as far as Saturn. Just solar system gets bigger and bigger and bigger. I have to stop for 1 second because I heard an interesting, fascinating fact. I wanted to talk about this. People talk about the planets, and you see the solar system, and here's the sun, and you see the planets and all these other things. The planets are never to scale to the sun, because you barely see the planets if you had the sun to scale. Jupiter's golf ball compared to it, or less. Marble, maybe. Here's something that you might not know that's an interesting fact. If you were to take the Earth and the Moon, which we think are pretty close together, but they're not. They're pretty far apart. I'd seen this statistic, and I thought about it because I grew up with astronomy. Oh, yeah, absolutely right. It just never occurred to me. Think about this. If you were to put the Earth here, and then you were to take Mercury and have it touch the Earth, and then have Venus touch Mercury, and Mars touch Venus, and then Jupiter touch Mars, Saturn touch Jupiter, Uranus touch Saturn, and Neptune touch Uranus. If you were to have all the planets touching up against the Earth, all of them would fit inside the moon's orbit. In other words, all of the planets of the solar system together, side by side, don't reach to the Earth's moon. That's how empty the solar system is. That's how tiny these planets are. So I think Sagan once referred to the solar system as the sun plus, they referred to the solar system as Jupiter plus debris. It's the sun plus debris. It's just a little scattering of dust. It's incredible how little matter there is in space. Anyway, that was a small digression. Here's your answer, Jennifer. Saturn. Saturn is the answer. Saturn moves very slowly against the stars. It moves so slowly against the stars that for all intents and purposes, we can consider it a fixed star in terms of when it's visible. Now, when Saturn is duly aligned with the sun, Saturn rises at sunrise, Saturn sets at sunset. You don't get to see Saturn. But the sun moves 15 degrees a month, I want to say. So the sun the sun appears to move. We're moving around the sun. So after a month, Saturn is 15 degrees behind the sun in the morning. It rises an hour before the sun does. And then after another month, it rises 2 hours before the sun. So my point is, if you're ready to get up early and stay up late, you can see Saturn most nights out of a year. But if Saturn is in the sky, it's not terribly striking. It's kind of a pale yellow. It's definitely yellow. And rather pale, it's not striking image. But you put Saturn in a telescope, and it's game over for anybody. It was game over for me, but I can back up that anecdotal evidence. I got a telescope when I was 12 in Bermuda. Just before I left for Florida, I saw one. I was waiting for a bus. I saw one in a camera shop, and I looked at this thing, and I was bored. I don't particularly care for cameras. Never really have been much of a photography guy. And I saw this thing on top of the glass, case in this photography shop, and it was a tripod, and it looked odd for a telescope because I thought it would be a little longer and thinner. And I bent it down to look at the lens on the big end of the telescope, and I said, well, there's no lens here. And I looked down into this open hollow tube, and at the far end was a mirror, concave mirror, like a makeup mirror. And I said, well, how the hell does that work? Turns out that for a telescope to work, you have to concentrate a large amount of light and focus it into a small amount, and that's called light gathering capability. It determines the resolution, how fine an image you get. The more light you gather and shrink down to a small space, the brighter the image, and also the more detail in the image. It's not just brighter, it's also resolution. The bigger the tube, the more light you gather, and now we have, when I was growing up, a 200-inch telescope at Palomar was the biggest one. We're much bigger than that now. So the more we bring in, the more we can gather, and the more we can magnify, and so on. And so the way you can gather light is with a big lens. A big lens will focus light, but a mirror will bounce it to a focal point as well. Newton invented that. That's called a Newtonian reflector. And I saw this mirror back there, a perfect mirror, has to be. Wow. So I talked to my dad, and he said, well, we'll get it for Christmas. You work, pay half, we'll get the other half for Christmas. So we did. And I took that telescope out on Christmas night, and I was outside as it was getting dark, and I'm looking around, and I'd bought Donald Menzel's Field Guide to the Stars and Planets when I first saw the telescope months before Christmas, read it, and again and again and again, memorized everything. So I'm outside. I got a pretty good idea what the constellations are looking for. I'm looking up here, and it's starting to get dark, and it's finally getting dark enough to see what's going on. I look up there, and I think that's pretty sure that's Arcturus. And I turned the telescope on it, and sure enough, what looked like a bright orange star in the telescope was a very bright orange star. Didn't look any different at all, just brighter. And I think, okay, if that's Arcturus, I'm pretty sure that must be Saturn. So got the little guide telescope with a wider field, because the big telescope's looking very, very narrow, the size of less than a dime. The other one's a little wider field, so you use the little telescope on the side to get it close, put it in the crosshairs. Now your big telescope should be more or less aligned. So I could see that there was something that looked different about Saturn. I couldn't really see it in the little guide telescopes, like 3-power telescope on the side. And then a Newtonian reflector, not only is there no lens, but you actually look at it at a right angle. Well, you do that with reflectors too. Instead of getting behind the tube, there's a little mirrored thing for the eyepiece. It's much easier to look down than it is to get under this thing. So I got the little eyepiece in there, low power eyepiece, wide field eyepiece, and I'd done the alignment just right on this thing, and I put that eyepiece in there and I racked it into focus, and I saw something that was the size of about a small BB, maybe smaller than a BB, and the rings around it, and I just let out a gasp, and that was it. It was like the Thunderbirds. I'll never forget that moment, ever, 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 ever. It was like, are you kidding me? Are you kidding me? And those exact words, Jennifer, I've heard probably 1,000 times. I was running the observatory at the Miami Space Transit Planetarium at the Museum of Science, Southern Cross Observatory there, with a bunch of other nerds and weirdos and vampires. And when Saturn was in the sky, we would have the telescope trained on Saturn, and just regular people who had no interest in astronomy would look down into that eyepiece, and they would see Saturn, and every single one of them would say, are you kidding me? Many people, I mean hundreds of people over the years, were convinced that had to be a slide, that we had a picture taped to the thing and that we had a backlit or something. And we would say, no, here, we'll move it around, we'll show you. Saturn in a telescope is magic. It's just magic, because it is the only solar system object. It's the only, with the exception of the moon, it's the only object you can look at with a small telescope that lives up to its advertising. That's a fair statement. I hadn't really thought of it that way. Saturn is the only object you can see in a small telescope that lives up to its advertising, where you look at it and you go, okay, by God, that's what I had in mind. And this is a really interesting question as I get into it, because I never really thought about this stuff before. And I guess I hadn't thought about any of this really before. I just knew Saturn was the answer. I didn't really know why until just the very second. Saturn is the only one that lives up to its billing, because Saturn does not have Saturn has a very, very bland surface. The aerosols on Saturn mean that, unlike Jupiter, which is filled with these roiling clouds, bands of clouds and belts of clouds and incredible detail in the clouds, Saturn's pretty plain. It's kind of a yellow milkshake, and it's lighter than water. Saturn would float in water. And there's very, very indistinct bands, but the color's a lovely kind of a gold, and the rings are the way they're supposed to look. And there's not a lot of detail in the rings either. So if you look at a photograph taken by a 200-inch Palomar telescope, or even really one taken by the Cassini space probe in orbit around Saturn, Saturn looks like a kind of a vague golden ball surrounded by these crisp rings. And in the smallest telescope, exactly, even in the smallest telescope, you can see the rings and the body of Saturn, and it's everything you thought it would be, and it knocks you on your butt. It knocks you down. It's so cool. It's just fantastic. Now, unfortunately, it's the only thing that's really fantastic in a small telescope. This is the big disappointment of amateur astronomy, and this is where you separate a lot of the wheat from the chaff. So let's take a look at the rest of the planets, because we'll deal with the deep sky objects in a second. Mars in a small telescope, even at a relatively high power, is a distinguishable disk. You can see that it's a disk, but it's a small disk. And under ideal circumstances, in a 12-inch telescope, which is a good-sized telescope for an amateur, if you would stay out all night and wait for the sky to get really still, which was rare in Miami because, first of all, you're so low. I mean, the observatory is probably at 12 feet above sea level. So all the atmosphere is above you. If you got to 3,000 feet, that you'd be above a third of the density of the atmosphere, so not above the third of the distance, but the heavy air is down low. So Mars, under ideal conditions with a decent-sized telescope, I have seen the polar caps on Mars, and I've seen major features like Syrtis Major, this giant kind of black triangle, but it's this big, and you can occasionally see, there's definitely a little white speck for the polar cap, and I kind of make out a little bit of a band here. So that's disappointing. Jupiter, under ideal conditions, you can definitely see bands of clouds. You can see that the disk is flattened, and the moons of Jupiter pop right out. Those babies are right there. You can see the shadows of the moons when they transit across Jupiter. You can see the red spot pretty clearly. But it's not... It's worse now, because when I saw Jupiter through a telescope, the best telescope in the world had a picture of Jupiter taken on a 60-inch telescope in the same atmosphere I was looking through. Even the best ground-based picture of telescope was nothing, really. I remember when Pioneer 10 got to Jupiter, and we saw the detail on the cloud banks. I was probably 14, I guess, with the rest of the grown-ups, and we're seeing these pictures come back, and I went, you gotta be kidding me. Jeez, look at the detail. Do you believe that? You'll never see that with a ground-based telescope. Couldn't see it with the Palomar telescope. Mercury is... I've seen Mercury with my naked eye probably 3 times. I don't think I've ever seen Mercury through a telescope. Mercury is so close to the sun that it's almost always lost in the glare of the sun under ideal conditions. If you have a very clear eastern or western horizon, you can see Mercury, but I don't even know if you'd be able to see much of the crescent. It's a very small planet, very hard to see. Venus is terrific. Venus is completely bland. It's utterly white in a telescope. The only thing that's cool about Venus is it's big. When it's close, it makes a decent size image, and the crescent is cool. Seeing crescent Venus because it's inside the sun, so as it comes around inside our orbit, we can see the sunlit part of the crescent. Crescent Venus is nice for a moment or two, but it's not something you just stare at. But Saturn is. Uranus and Neptune I've seen in telescopes. They're just a little itty-bitty, tiny little vague green BB and an even smaller, tinier little pale blue BB. That's about it. I'll save the big one for last. I won't. If I don't get it now, it'll be out of the way. When you start off in amateur astronomy, views of the moon are also as powerful as Saturn. The moon in a telescope will take your breath away, because the craters are like, oh my God. As with Saturn, the moon lives up to its billing, I suppose. I should have mentioned it earlier, but the moon and astronomers have a very, very dysfunctional relationship. The moon, you really do need a moon filter. I used to look at the moon without a moon filter, and if you're out at nighttime, when you put that moon up to your eye and all that light's coming in, it'll blind you. I mean, it won't physically blind you, it won't hurt you, but it's bright. So they actually, when we bought that telescope, there's a little piece of glass called a moon filter, green filter that cut a lot of the light down. Had a glass sun filter too, which was at the focus, and that's actually very dangerous. If you're going to look at the sun, you want an aperture over the front of the telescope, not at the bottom where all the light is and heat is concentrated, because those things have been known to crack, and that's the end of that vision. But the moon will show you craters. A lot of people think the full moon is the way to look, but the full moon is the worst time to see the moon because the light on the full moon, definition of full moon is it's noon on the near side of the moon. So all the light is straight down. There's no shadows at all, and the moon is very washed out. And the rays from the craters, the white ejecta stands out, but the moon's not very interesting at full moon. But even a couple days on either side of full, you can start to see shadows. And first quarter moon is really cool. The black shadows really stand out, and you see the craters, and you zoom in there, and you see rills and mountains. It's pretty neat. But you get tired of it after a while. And the problem with the moon, of course, is that the moon blows everything else out of the water. If the moon is up, it's time to go home. As far as astronomy is concerned, the moon kills everything that's not a planet, which leads us to the other objects that you can see with a telescope. And I'll kind of come back and wrap this up for you if you'd like. The other objects we call deep sky objects, and they consist of basically two different things. There are nebulae and there are galaxies. For most of the history of astronomy, people thought they were the same thing. I did a post on my Facebook page not too long ago, just a couple days ago, showing what the Andromeda galaxy would look like if it was actually bright. It's many times the size of the full moon, many times. And it's spectacular to look at if you could only see it, but it's so faint. So deep sky objects are very, 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 very faint, and they break down into two different categories, as I said, nebulae and galaxies. Galaxies are island universes like our own Milky Way, and they're out a great distance on a pitch black night with a decent wide-angle telescope, low power telescope. I think I've seen a little bit of the structure of this gray-green oval. It's a gray-green oval. It's brighter in the middle. That's about all you get. I think on a dark night I might have seen a little bit of darkness in that gray mush, but it's nothing like what you see in time exposures. So those are galaxies, and Andromeda is far and away the most spectacular, and they're basically just little smudges. And frankly, in astronomy, just identifying it, oh, that little smudge there that I can't make anything out of, yep, that's M33. That's the triangle galaxy, I want to say. Yeah, okay, cool. All right. So that's galaxies. Now, the other things are nebulae, which is the same word as cloud, nebulous, or, it's a word for cloud. And they are virtually indistinguishable from galaxies and small telescopes. They're just little smudges of light, but they're very different. They live inside our own galaxy, inside our own Milky Way. They're not extragalactic like other galaxies are. And there are two different flavors of nebulae. There are basically, I want to say call them emission nebulae and planetary. I'm not sure about planetary nebulae. I forget what the other name might have been. Basically, nebulae are the birth stages and the death stages of stars before they become stars and then after they stop being stars. The Orion Nebula, the most famous by far, which is nice in a big telescope, but it's still just a gray-green smidge of light. You can see some detail, but it's not like, wow. You can definitely see detail. It's worth looking at, but you got to be dark. You can't do that in the city. You can't see it. It's so faint. But in a telescope, the Orion Nebula, you can see some of the shape and the structure, and it's definitely brighter in the middle, and the stars of the trapezium are in the middle, lighting it up. It's really pretty. It's nice. But it's not like what you would want it to be. There's no reds. There's no blues. You don't see any detail. There's no cloud structure. None of it's too faint. The Orion Nebula, the Trifid Nebula, the Lagoon Nebula, all of these nebulae are giant clouds of dust and gas from the corpses of previous stars, and they are coalescing over time to make new stars. They're star nurseries is what they are. It's where stars are made. And then occasionally you can find nebulae like the Crab Nebulae or others where after the star explodes, a supernova will blow a bubble of gas out, and it's called a planetary nebulae because that little bubble looks like a faint planet. And those are usually even less detailed than the other nebulae are. And they're fun to identify, but you can't really see much of them. Here's the thing that's so heartbreaking, and I hate to break this to people who are big fans of science fiction, but it's something we just all have to face. We don't have to like things, we just have to be true. When you look at the Andromeda Galaxy at nighttime, it's very dim. It's just barely visible as an oval. And likewise, you would think, well, gee, I guess when you got close to it, right? If you in science fiction things, if we were to get in a starship and fly to the Andromeda Galaxy, as we got closer, needless to say, it get brighter and brighter, and it would look exactly the way it was. We'd hang out there some distance away, and we'd look and we'd see all the details we see in these time exposures. Some of them are an hour. No. And the reason it wouldn't look any brighter, if you flew right into the middle of the Andromeda galaxy, it would still be a ghastly, pale, gray-green ghost. The reason we know this to be true is because we happen to be living right smack in the middle of the second biggest galaxy in the local cluster, which is the Milky Way. And when you go out at nighttime and you look at the Milky Way, you don't see star lanes and you don't see all these pillars and you don't see all this cool stuff. It's just gray. The Milky Way is gray, and so is the Andromeda galaxy, because the light is so diffuse that you cannot see that structure without long, long time exposures. So the sad thing is that if you ever saw the Starship Enterprise whipping on its way out to Andromeda, like it did in that one episode with the energy barrier, where no man has gone before, I guess, it wouldn't be there, and it wouldn't, as you got into it, you wouldn't get to see all the structure. It'd just be gray goo, just the way the Milky Way is. It's just sad, but it's true. You just have to live with it. Now you can start getting into amateur photography. I never particularly did, but there you go. So here's your answer for you, Jennifer. Saturn, the moon, they're striking. Jupiter often puts on a good show. Mars, on ideal conditions, when Mars is in opposition, when it's not on the other side of the solar system, when we're right in front of it, it can get pretty cool sometimes. But if you really want to blow people away, use Saturn. If Saturn isn't up, get a photograph of Saturn, make a slide out of it, tape it to the inside of the eyepiece, put a little light in there, and that will do it, because people will not believe how good Saturn looks. That was really fun. I could talk astronomy all day. Yeah, I think I'll do this.